Alright guys, so we're taking a look now at some more sequences and equations, okay? So we've talked here about the recursive equation pretty extensively, okay? And we've talked about how we go a sub n equals a sub n minus 1, then we put our growth, also in arithmetic sequences called our common difference, okay? Then we also have to have our starting point, and we like to go to the beginning, not to the first term, and do a sub 0, okay? So today we're going to kind of talk about how we can use a table to help us figure out the explicit equation, okay? So we're going to kind of do both recursive and explicit, but focus more on the explicit equation, okay? But again, for either one, it always comes down to where does it start and how is it growing, okay? So we've got a sequence here. We're just going to do sequences, not story problems or pictures, just the number sequence. So remember, okay, this is our n, this is a sub n, okay, our input and our output, and we always have our 0 term, our first, our second, our third, our fourth, fifth, sixth, and so on. We could just put our nth term, okay. So our negative 37 isn't the 0 term. It's the first term. Okay, pretty simple to fill that out. Okay, and then can we figure out the pattern and keep going? Okay, so looks like from negative 37 to negative 7, looks like we're adding 30. Okay, then from negative 7 to 23, yes, still adding 30. 23 to 53, adding 30. So this would be 83. And this would be 113. Okay? So, for our recursive equation, we go a sub n equals a sub n minus 1, just the next term, right? Remember what it stands for to get the next term. It's the previous term, and in arithmetic, plus the growth, or plus the pattern. Okay, so our pattern is plus 30. So write plus 30 out there. Okay. Now, where did we start? So if we go backwards, okay, what plus 30 would equal negative 37? And remember, because they're negatives, it kind of works backwards, so it would actually be negative 67. So we start at negative 67. Remember, we need both of these to make this recursive equation match this pattern. Okay. So our starting point, negative 67. Our growth, or common difference, plus 30. Okay? So now let's see how we then take this concept and we move it to an explicit equation. Okay? And an explicit equation, by the way, guys, you should be copying down all this stuff up here, okay? But an explicit equation works under the same idea. Okay? Let's start with that. So remember, an arithmetic pattern, okay, it grows by adding or subtracting the same number each time, okay? So we're only talking about the arithmetic pattern here. So the recursive, remember, that's how our brains think, okay? They mimic our brain with patterns and looking at the previous, right? And so we go to get that next term, it's equal to the previous term, plus or minus our growth, or our common difference, as it's called. We'll just put CD for common difference. Then we go a sub 0, and that's our start number. Okay, so that growth and the start number is part of the recursive. Remember, the n just stands for the term. So if I want the 5th term, I need the 4th term result, then I can figure it out. Now, and so they just connect outputs. Okay? So looking here, my recursive connects all these numbers together. Okay? Based on which term they are, but we don't use these numbers to figure these out. We use the previous. So for 7, I don't use 7 and plug it into something and get this answer. I look back at 6 and use that plus the growth to get my next answer. Okay? So that's what I do in that case. Now with an explicit equation, okay, with an explicit equation, this one now connects our input to an output. Okay, so now it changes the game. And the benefit is this. If we look back at this table, okay, which you should have been following along and writing stuff down, if we look back at this table, okay, it's easy to find the 7th or the 8th or the 9th term using our recursive concept, our recursive equation. But what happens when all of a sudden now I want to go, and let's actually erase that. Let's say I want to go to the 100th term. Okay? Do I really want to keep using my numbers to get to 100? Okay. Now, if I have a calculator, it could make it fairly easy, right? Because once I figure out the pattern, then I just keep adding and use that recursive concept. But what if I could just plug in 100 to an equation and come up with my answer? That's where the explicit comes in. Okay. So when you're going close or small numbers, recursive is great. But explicit helps us with the bigger ones and when we don't want to have to rely on the previous answer. So the way we think about an explicit is that we take our output, in this case a sub n, okay, and it equals not an a sub n minus 1 or a sub 100 or anything like that. Okay, we think, okay, where do we start? Okay, just like up here, and then we add our growth to it. Okay, that common difference, and then, you know, because we're going to keep adding that growth, we generally have a variable here, okay, with our growth, and that's all there is to it. Okay, again though, we're using the same pieces that we used in the recursive. Okay, so let's see what that looks like. So if we look at this, okay, here's the way to think about it. Okay, so this expanded and condensed, here's what I'm saying. Okay, so we start with negative 67, right? Do we add our common difference at all to it? No, we don't. But let's take a look at this first term. This first term, we still started with negative 67, but how do we get to negative 37? Oh, we added 30 once. Okay, so we get to the second one, negative 67. Well, this time, to get to negative 7, we added 30 twice. Okay, look at the third term. To get to 23, we took negative 67 and we added 30 3 times. Hopefully you see a pattern here. Okay, start at negative 67. How many times are we going to add 30? Hopefully at least one of you guys shouted out the answer. 4 times. Okay, and the fifth term, 5 times, right? I hope I can write small enough to fit them all. Uh-oh. Okay, and then for the 6th term, we would add it 6 times. And I was using too much space to begin with, wasn't I? Let's see if I can cut this one into 2. There we go. Okay, so if I'm going to the 100th, I would add 30 100 times, right? So how do I shortcut write that repeated multiplication? Okay, well, in the first one, I'd go negative 67 plus 30 times 1. Not too hard to write that one. Okay, the second term, negative 67 plus 30 times 2. Then the third term, negative 67 plus 30 times 3. Then negative 67 plus 30 times 4. Negative 67 plus 30 times 5. Negative 67 plus 30 times 6. And this would be negative 67 plus 30 times 100. Okay, so what would our original be? Well, negative 67 plus 30, but we didn't add 30, so we times it by 0. Okay, so what we should notice here now is see these numbers here on our input? Because like we said, the explicit connects the input to the output. Okay, so see, we've got all those numbers. That's how many 30s we have. Okay, I can see it again right there. 0 here, 0 there. 1 here, 1 there. 2 here, 2 there. 3 and 3, 4 and 4, 5 and 5, 6 and 6, 100 and 100, and n. And this would look like, you got it, negative 67 plus 30 times n. Guess what? That's my explicit equation. I can write it a sub n equals negative 67 plus 30n. Okay? Now, could I write this a sub n equals 30n minus 67? You betcha I could. Could I write this y equals negative 67 plus 30x? Yeah, I could. In this case, we are using n and a sub n, and that's kind of what I want us using first. But we are going to get to the point where we start using what you're more familiar with, the x's and the y's. Okay? So, but we can see, notice how here we had a sub n minus 1, referring to the previous. Here I have an n. Notice it's not a sub n, so it's actually this number we plug in there. And because it connects an input to an output. Okay? All right. Let's explore this a little further, okay? All right. So, if you know the pattern, you'll probably be able to get this moving. So we got n a sub n for our input and output. Okay? So, 0 term, our beginning, first, second, third, fourth, fifth, sixth, 100th, and n. So we start at, well, we don't start. Our first term, I got to make sure I say it right, negative 23, then negative 14, negative 5, positive 4. So it looks like we are adding 9 each time. So our common difference, our growth, is plus 9. So this would be 13, and then 22. Okay, not sure what these two would be yet. So going backwards, okay, would be negative 32, right? Because negative 32 plus 9, negative 23. Okay, so our recursive, we know where we start, we know how it grows. So I go a sub n, my next term is equal to my previous term, plus 9, and then we started at a sub 0 at negative 32. Okay, now for my explicit equation, so remember, negative 32 here. How did we get to negative 23? Well, we took negative 32 and we added 9. How did we get to negative 14? We took negative 32, that's where we started, and we added 9 twice. Okay, to get to negative 5, we started at negative 32 and added 9 3 times. For negative 32, we added 9 4 times. Right? To get to our number of 4. Then to get to 13, we took 32 and added 9 5 times. And finally, to get to 6, took negative 32 and added 9 6 times. Okay, which when we're looking at those contextual problems, this is exactly what we're doing, right? So, to condense that, we go negative 32, and how many times did we add 9? Well, we added it 0 times. Okay. To get to negative 23, we took negative 32, and we added 9 1 time. Then we added 9 2 times. Then we added 9 3 times. So 9 times 3 is adding, right? It's that shortcut of repeated addition. Because we're all about, in math, taking shortcuts and making it easier for us. So it would look like that, right? So this one would be negative 32 plus 9 times 100. And this one, negative 32 plus 9 times n. Again, we should see our n's right there. Okay? They're the same exact numbers. And that's how we connect it. And it's because that's how many times we're adding our growth to it to get to our next result. So our explicit equation, a sub n equals negative 32 plus 9n. Or again, you could have written it 9n minus 32. Same exact thing. Okay, so hopefully this seems pretty easy. All right. Okay, now let's take a look at the next ones. So let's do these two again together, and then I think I'll give you guys some time to try these on your own, and we'll kind of check as we go, okay? So again, started out a sub n minus 1, okay? On all of these, a sub n, oh crap, what am I doing? No, n and a sub n for my input and my output, huh? There we go. For the recursive, a sub n equals a sub n minus 1, and a sub 0 equals, right? That's what we always do on recursive. We always are going to have those parts. Always, 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 always. Okay? So then, I label my table. Okay? Down here as well. And then we can get jumping through this pretty quick. All right. So, looking at my pattern, my first term is negative 31, then negative 21, negative 11, negative 1. So it looks like, what are we doing each time? We're adding 10 each time. Okay? So going backwards, my starting would be negative 41. So, my growth, my common difference goes right there. My starting goes right there. Okay? So then, if we add 10 to negative 1, that would actually give us positive 9, then positive 19. Okay? So, expanded, negative 41. Condensed, negative 41 plus 10 times 0. Because we don't add any 10s in that case. Okay? Then negative 41 plus 110. So, condensed, negative 41 plus 10 times 1. Right? Because we're matching how many times we would add 10. We can think about it visually like this, too. Okay? Like if I'm going to this fifth term, right? I started at negative 41 and added 1, 2, 3, 4, 5. Okay? Or writing it out this way, negative 41 plus 1, 2, 3, 4, 5. Or negative 41 plus 10 times 5. Okay, so again, we can see those 5 tens. They match up. Each 10 matches up with one of those numbers. Okay, so negative 41 plus 10 plus 10, or negative 41 plus 10 times 2. Negative 40, oh, that's a 1, not 40. 41 plus 10 plus 10 plus 10, because there's 3 of them this time, right? Those 3. So negative 41 plus 10 times 3. Then we add 10 4 times, or negative 41 plus 10 times 4. Then negative 41 plus 10 plus 10, and we do it 6 times, which we start feeling like, oh man. Now imagine doing it 100 times, right? That'd be way too many, which is why we don't like those. Or n amount of times. We don't know what that would even look like. Oh yes, we do, because it would look like these ones. So negative 41 plus 10 times 100, and negative 41 plus 10 times n. So our explicit, a sub n equals negative 41 plus 10 times n. Okay? And there's our recursive and our explicit equation. Okay? All right. Let's do one more together, and then I'll give you some time to do some on your own, and then we can double check them. Does that sound like a plan? Okay. All right. So, my first term is 30, then 34, then 38, then 42. So my common difference, we're growing by adding 4. Okay? So my growth, add 4. Then where do we start? Well, going backwards, subtracting 4 from 30 would give us 26. So our 0 term, our beginning term, our starting term is 26. Okay? So we begin all of these at 26, don't we? Even these two we begin at 26. So just writing it in different kind of format just to see if maybe that helps some of you see it a little differently. Okay? Then if I think about it, to get to 26, how many times did I add 4? Well, I didn't. So when I add 4, we times it by 0 to get rid of it. Okay, now for 30, I had to add 4 once to get to 30. Okay, actually, I'm going to do these in purple. To get to my second term of 34, we add 4 twice, or 8, right? Which is 4 times 2. Okay, then to get to 38, we add 4 3 times, don't we? Or we times by 3. Okay, so to get to 42, we add it up 4 times, or we multiply it by 4. Okay, now my next number, right, if we add a extra 4 to that, so instead we're adding 4 a 5th time, okay, would actually be 46. And then 4 more would put us to 50. Because if we add 4 6 times, see if I can get them all to fit in here. Hopefully you have smaller handwriting than I do. Okay, we added 4 6 times. And if we did it 100 times, we would add 4 100 times, right? Which is 4 times 100. And if we did it n times, we would add 4 n times. Okay, so again, the formula we should note is that we've got a sub n equals, actually let's do it in a different color. A sub n equals our starting number, which was 26, plus, oops, why did I put that dot there? Plus 4, and how many times are we multiplying by 4? N amount of times. Okay, again, a sub n equals 4n plus 26 is the same thing. Okay, so, alright guys, so we've got a few more to take a look at here. So we've got 4, or 5, 6, 7, 8, 9, and 10. Okay, so we want to do all of these. So let me actually go back here. So here's what we're going to do. Let's have you do 2 at a time. Okay, so let's give ourselves like 10 minutes. Is that plenty of time? Hopefully it is. Okay, so let's pause this, give you 10 minutes, and then we'll take a look at the answers. All right, so your guest teacher should have paused that for us. Okay, so if not, pause it now. If so, then let's take a look at what we did. So looking at this, okay, again, okay, so we can fill all this part in because we know that's what it's going to look like. Okay, a sub n equals a sub n minus 1, and a sub 0 equals, and then a sub n for our explicit equation. So you guys should have already taken a look at this one. If not, pause it now. If so, let's move on. So our first term was 3, then 203, 403, 603. Pretty easy to see we are adding 200 each time. So 803, 1003. Okay, so going backwards, we should realize that's going to be negative 97. Because negative 97 plus 100, right, gives us 3. Or negative 97 plus 100 times 1 would give us that number. Okay, so for our recursive, we know that's plus 200. We know that's negative 97. Okay, so expanded negative 97 plus 100. By 100 I meant 200. My goodness. So that would actually be a different number, wouldn't it? You guys were probably screaming at me, Mr. Rideout, you're wrong again. And it happens to me, doesn't it? That's an easy fix for that one. I'm going to struggle to put these all in, aren't I? Okay, plus 200. Plus 200. There we go. Now it works, right? Okay, so negative 197. All right, so we take negative 197, and we add 200 twice to get to 203, or negative 197 plus 200 times 2. If we're doing it to the third term, We started with negative 197 and we add 200 3 times. Or we multiply by that adding of 200 by 3. Okay, hopefully by now we're catching on to this pattern here of how things are working. So negative 197 plus 200 times 4. Okay, so honestly, with these big numbers, I know I'm going to add 200, 5 times, right? So negative 197 plus 200 times 5. And then I'm going to take negative 197 and add 200 6 times, right? So negative 197 plus 200 times 6. So this one, negative 197 plus 200, and we times it by 100. That'll be a big number, right? And for our explicit equation, we get that. So negative 197 plus 200 times n. And that's what it should have looked like for number 5. Okay. Number 6, same idea. Okay. We would have started with 32, then 26, then 20, then 14. So it looks like we are subtracting by 6, aren't we? Okay, so we're subtracting by 6. That's our growth. Going backwards, adding 6 to 32 would say we start at 38. Okay, so subtracting by 6, that would be 8, and that would be 2. So we start at 38 each time. And then we subtract by 6, which is the same as adding by negative 6. So we still kind of treat it the same exact way, even though it's minus. So that's what it looks like expanded, then condensed. 38 minus 6 times 0, 38 minus 6 one time, 38 minus 6 two times, minus 38. So it doesn't matter if it's addition or subtraction, we still treat it the same exact way, don't we? Okay, and I am quickly running out of time because they don't limit me to a half an hour on these. But when we get to the n term, 38 minus 6 times n, right? Again, that same pattern of the inputs, connecting the inputs to the outputs. So 38 minus 6 times n. Okay, so pause the video right here, take another 10 minutes, and try to do 7 and 8. All right, so let's take a look at this side. All right, for sake of time, I've kind of already filled it out, but again, we go with the pattern. Starting, our first term is 27. We add 3 each time. Going back minus 3, we get 24. So starting at 24, common difference at 3. So we added 3 each time, and we started at 24. Okay, then we expand it out, and we see we're adding 3 for however many inputs we have, which means we're actually multiplying by 3 for that repeated addition. And we get 24 plus 2m, 3n. Okay, so there's our recursive, there's our explicit. If you need this paused, have it paused so you can make sure you check everything. Okay, number 8, same idea. We realize that we are subtracting 2 each time. So we start at negative 35, going back. So we start at negative 35, and we subtract 2 each time. There's our recursive equation. When we expand it out and realize that we're just repeatedly minusing 2, we get our explicit equation of negative 35 minus 2n. Okay, so pause it now, and we'll take a look at the last 2. Okay, so in this last minute, let's take a look again. So first term, negative 12. We realize we're subtracting 5 as we go. So going backwards, our starting is negative 7. Common difference, negative 5. So we subtract negative 5, depending on how many inputs, because that's how many times we subtracted. Condensing it, we realize we're just multiplying by it. So recursive equation is minus 5 starting negative 7, start at negative 7, minus 5n. Okay, and the last one we can see here, again, if you can't catch these, pause it, but we realize that our pattern is adding 7 and our starting negative 6. So negative 6 plus 7n is our explicit and recursive, and hopefully you've caught on where these starting and growths go, because the pattern is all about our zero term, where we start and grow.